Monday, along with the next part of the review we're going to do. So we're okay with these graphs of parabolas in Vertex form worksheet? Or they're still like really blank and we just didn't do them and we're using them today? No? Nothing? Alright, so if we look at properties of quadratics, I just want to go through at least like one example with you to talk about those key properties. So yesterday we said that the parabola or quadratic always has a domain of all reals. Fantastic. Okay, next, the range. In this case, we're given the graph and not the equation. So you need to look at the graph and identify your vertex. So sometimes I might not do these in order. I might say, okay, where's my vertex? So my vertex is on this dashed line and that dashed line, which is at 2, -4. If my vertex is at 2, -4, what does that make my range? First off, are the y values going to be bigger or smaller than the min? Bigger. So my range is going to be greater than or equal to. Okay, what is the range always greater than or equal to? What value? K, awesome. So what's my K value in this case? -4. So my range is greater than or equal to -4. X-intercepts. X-intercepts are where it hits the X axis. X-intercepts are where it hits the X axis. Kind of scared to click this. Okay, so the X-intercepts are at -2 and +6. They're at -2 and +6. The y-intercept is where it hits the y-axis. So in this case, the y-intercept is this point here. So that's at -3. The y-intercept occurs when x is 0. So you could write it as 0, -3. You could also just say -3. Thank you. The min value is at k. So we know this is a min because that graph is open up. The lowest point is here. That is at -4. So the minimum value is the y value. So in this case, it's -4. Axis of symmetry is always x equals. So like, don't lose any points for that. You just auto want to put x equals. And then in this case, it's equal to the h value or the x value of the vertex. So 2. Is my graph open up or open down? Well, it's open up because it looks like a smile. Down would look like a frown. So number 2 would be a down graph. And the A value would be negative. Like, I know instantly looking at this that it would be y equals negative something because my graph is open down like a frown. So I know that the A value is negative. Okay, so you're going to do the domain range and all those points for the next 3 examples. And then again, you're going to graph everything in number 6. So I would want you to give me, your key points. What's the vertex? Is it a min or a max? Where's that at? And then your table of values. So that's your x plus h, ya plus k, where you always have your 0, 1, 2, and 0, 1, 4. Okay, determine whether each function has a max or a min. So a graph will have a max if it's a negative on the x squared term. So there can be a number in here. It can just be x squared. But you have a max if it's a negative on the x squared. And you have a min if it's a positive being multiplied to your x squared. So like 7, a value is positive, therefore this has a min. Here, a value is negative, therefore this has a max. And I want to do one of the ones off the back, because these are the ones I think are the trickiest. So your vertex is always h, k, and a point on a graph is always considered x, y. So in terms of vertex form, our equation is y equals a, x minus h squared plus k. So if we're given the vertex and a point, we're given the y, the x, the h, and the k. So we have to use these key pieces of information to find the a value so that I can get my equation in terms of y equals fill in a, x minus fill in h, squared plus fill in k. So what we're going to do is use h, x, and y to plug into that equation. So it would be negative 5 equals a, negative 2 minus, because that's part of the formula, h, which is negative 3, squared plus k, which is 7. Now, all this is using your order of operations to solve for a variable. So it's negative 5 equals a, minus a minus is a positive, 3 minus 2 is 1, 1 squared is 1. So you get negative 5 equals a plus 7. To solve for a, you're going to subtract 7 from both sides. And I get a equals negative 12. So once I know a, I also know h and k. So to write the equation, I'm going to fill in the a I found, x minus the h I was given, squared, because that's what makes it a quadratic, plus k. And if you want, you can simplify the minus a minus. So my equation in vertex form and my final answer is y equals negative 12, x plus 3 squared plus 7. So you have like the next 20 minutes to work on this packet and the problems that are around all of the examples we just went over. I'm back here to help you at any time if you get stuck. This is recorded, so if you get stuck over the weekend, you can go back and watch the